Hello, we are now doing the recording where we do time series. And we're doing forecasting seasonality with trend. And we're doing that using seasonal indexes. So the method for making seasonal indexes when we're dealing with data that does not have a trend is pretty straightforward. All we need to do is take the average for a given season, and then divide that by the overall average, right? So if we take the average for all Januaries and divide that by the average for all months, we'll get the seasonal index for January. So I'm not going to be showing that part in Excel because it's really just pretty simple. What I'm showing is the harder thing, which is when we have to do a seasonal index when we do have a trend, right? So we have this glass slipper monthly revenue graph, and we can see there's a lot of seasonality, big swings with seasons, and also there's a bit of trend. If you look at the valleys here, they're going up over time, and if you look at the peaks are going up over time too. And if you look at any given point on the pattern, you'll see it does seem to be going up. So we have a bit of an upwards trend, and we have some seasonality. And the way we're going to deal with this is first we are going to find the seasonal indexes. And this is going to take a little bit of work. After we have the seasonal indexes, we're going to remove seasonality from the data. We're going to have what's called deseasonalized data. All that's going to be left there is going to be trend and random fluctuations. Then we are free to forecast that using whatever method we like from all the methods we've learned so far this term, right? We could use exponential smoothing with trend. We could use linear regression. It's up to us. And then once we've made those forecasts, we can add back in the seasonality. So that is the plan. So I'm going to start by getting what are called centered moving averages. And the reason we need centered moving averages is because when you have seasonality and trend, the fact that the data is moving up over time is going to make December always look higher than January or whatever, even if they should be at baseline the same. December is going to be a little bit inflated relative to the previous January because it's had 11 months of growth using the trend, right? And so that when we do seasonal indexes without centering things, what's going to happen is the things that should be attributed to trend are going to be instead attributed to seasonality, and our deseasonalized data is not going to be nice and straight. It's going to be jumpy. We're going to have like flat line, then a jump, and then a flat line, and then a jump. And it's not going to be what we want. And there's a picture of that in the lecture slides if you want to take a look at that. So what we need to do is we need to center the data. That means that if I want to know how does September compare to other months in the year, I need to look at not September as it is in this calendar year, because September is near the end of the year, or it's closer to the end than it is to the beginning, right? This is not centered. What I need to do is I need to center it, right? So I need to get a year centered around September. So I need to highlight something like 12 months around September centered. And this is what my centered moving average is going to do. Now, it's a little bit of a problem that we have an even number of months in the year. If there was an odd number, it would be easy to center it, right? Just as an example, if I have Monday, Tuesday, Wednesday, Thursday, Friday, and then Monday, Tuesday, Wednesday, Thursday, Friday, etc. If I have this sort of seasonality, there's 5 days in a week. So if I want to center on Thursday, I can just do this. Thursday is in the middle of those 5. I've highlighted a full week of data, and Thursday's in the middle. So that's great when you have an odd number. But because we have an even number, right, how do we center on, say, July? Well, the way we center on July would be, we would need 5, this is 1 month, July is 1 month. To make 12 months, we would need 5.5 months above it and 5.5 months below it. Okay, so then what are we going to do? 5.5 months above it, we're going to do 1, 2, 3, 4, 5, and then half, right? So we're going to do February, March, April, May, June, and half of January. And then going down, we're going to have August, September, October, November, December, and then half of this January, right? So we're going to have a full year, but it's going to include both of these Januaries, and we don't want to double count January, so we need to cut each January in half. All right, so the fact that we have to cut things in half means we can't just use the average formula. We have to use we have to sort of do it a bit more manually. So how does that look? We're going to do the sum of these, right? So February through December, we're going to add those all up normally. And then we need to do half of each January. So 0.5 times this January and 0.5 times that January. And then I need to divide by 12. So I need to make sure I do brackets. Common mistake here is to forget the brackets. Don't forget the brackets. You'll get very weird numbers if you forget the brackets. Okay, so this is my centered moving average. I've added up essentially 12 months, right? 11 months plus 2 halves is basically 12 months and divided by 12. So it's an average. And now, why did I start in July? I started in July because what happens if I move up here? Oh, I get an error because what happened? The numbers slid up, and instead of selecting the next number, it selected this label. It selected the word revenue. And so it couldn't calculate that. Right? And so that's going to happen anytime for any of these, right? Basically, because it is a 12-month moving average, if you remember with moving averages, for a 4-month moving average, you would lose 4 months. Here we're doing a 12-month moving average, so we're going to lose 12 months. But it's centered, so we're going to lose 6 on the top, and we're going to lose 6 on the bottom. Right? That's 12 months that we're missing. And that's just what happens. So the rest of it, we can just copy and paste this down. And this is going to work just fine. Everything slides along nicely. You can see I'm always centered, right? I'm doing this January, and January here is centered in this year. So I have my centered moving averages. The next step is to make what are called seasonal ratios. A seasonal ratio reflects how well did a particular month perform or a particular season perform relative to that centered year that was centered on that month, right? So how did July compare to the rest of the year centered on July? Well, all we're doing is we're dividing, right? So this over this, I get, in this case, 0.799. That's about 80%, right? So what happened was July, the performance, the revenue was about 80% of the average for the whole year. And if I copy and paste this down, I'm going to get different indexes, right? So some months are performing well, right? January, like you see on the graph, the Januaries are always good. This January is like 146% of the average, right? What about this January? That's 143% of the average, right? So the Januaries are doing well. The Octobers and Septembers are doing worse, right? And it's just this nice repeating pattern, which makes sense because we got seasonality. And we still have these blanks. Okay, so now we want to do seasonal indexes. Right? So we want to do seasonal index. And so we want to do the seasonal index for January. So we want to do an average. So the way I showed in lecture was with the sum if divided by count if, but I realized later that there is an average if formula, which is actually just faster, right? An average is a sum divided by a count. So this average if formula should give us exactly the same thing as the sum if divided by the count if that I showed you in class. So we're going to use the average if formula and be even faster than we were when I did this in lecture. So the way the average if formula works is it's going to look in a particular range, and the range we want to look in is all of these months, but only the ones where we actually have ratios. We don't want to look in anywhere where we don't have data. That would just give us problems. And in those months where we have data, we are going to be looking for whatever month we're in, right? So I'm right now in this row where I'm referring to January, so I'm looking for Januaries. So the next thing, the criteria is 1. So what Excel is going to do is it's going to look in this range for any time it sees a 1. Anytime it sees a 1, that's a January. I want to average something. And what am I averaging? I'm averaging these numbers. Now I need both of those ranges to be static. So I'm going to put my dollar signs on them. Make sure when you're making them static, you put dollar signs on everything. The only thing that's not static is my criteria, D2. And so this is going to take all of these numbers and it's going to average them, but only if it sees a match over here, right? So it's going to average only the Januaries. And then when I copy and paste it down in the next row, it's going to look for 2s. So it's going to look for only Februaries and it's going to average the Februaries and so on. So when I copy and paste this formula down, there are only 12 seasonal indexes. So technically I only need these, right? I could make do with just these 12 numbers. But the formulas in Excel are going to be a little bit easier to type if I just copy and paste it all the way down. Just make sure you know that these 12 are the same as these 12, which are the same as these 12. It's just the same 12 numbers repeated 3 times. Okay, but these are my seasonal indexes. And this would be all good, except there's one little nagging problem, which is that these have to add up to 12, and they don't. If I look at the sum of those 12 seasonal indexes, and it doesn't matter if I look at the top 12 or the bottom 12 or whatever, right? If I look at the sum of those 12 seasonal indexes, I'm getting not 12. I'm getting close to 12, but not quite. It's off by a bit. I need to fix that. So the way I'm going to fix that is by rescaling. So we're going to call this the rescaled seasonal index, or the rescaled index if you want to just be short. So the rescaled seasonal index is going to be my seasonal index, but I need to force them to add up to 12. So I'm going to take this number and I'm going to divide by that sum, right? The sum of these 12. I'm going to make that static because I want that sum to just be the same number all the time, right? That was the number I did not want it to add up to. That was the 11.98. I'm going to divide by that 11.98 and I'm going to multiply by 12. So what I've done is I've just rescaled that number a little bit. It's almost the same, but it's a little bit bigger because now, I'll copy and paste that down, they're going to add up to 12, and I can check that. The sum of these 12 numbers is 12. This is good, right? So now these are the actual final seasonal indexes that I want to use. So that is the procedure for calculating seasonal indexes. All right, take a breath. Let's go on. Maybe pause the video, get a glass of water, whatever you need, right? Because now we're going to go on to using these seasonal indexes. What we're going to do with them is we're going to deseasonalize the data. Deseasonalized revenue. Oh, and I suppose I can show you what happens if in these ranges, what if you did select everything with these ranges? The answer is, because I'm now using the average if formula, it would still work. If I was using the sum if divided by count if, it wouldn't, right? So actually the average if has this advantage where I can actually select everything. As long as I make sure I have these blanks here, as long as these things are not numbers, right? If I have like zeros here, it's going to screw things up, right? I can't have zeros. I can have blanks, right? Blanks are fine. Text is fine, right? Text doesn't screw things up. Zeros would screw things up, right? So make sure that whatever these are, they're not numbers. Blanks, dashes, text, it's all good if you want to select everything. Or you can do like I showed you and just select the range where you have seasonal ratios. It's up to you. But I did want to note that this is something that we can do if we use average if. We could not do it if we use count if, because the denominator wouldn't match up nicely. Anyway, deseasonalized revenue. We're going to take our actual revenue and we're going to divide by the seasonal index. And this is easy. We're just going to, just check that out. Revenue divided by rescaled seasonal index. Copy and paste that all the way down. Done. We've deseasonalized our revenue. What does this look like? I'm going to add this to my table so that we can see what this looks like. Okay, so there we go. And you can see now there is a trend, right? The line slopes upwards a bit, and there's some random fluctuations, but there's no obvious seasonality anymore, right? There's no obvious repeating patterns. This little wiggle here, it may not be consistent, right? It may be at slightly different times or whatever. Right here, this wiggle seems to be starting in May. This wiggle seems to be starting in June. This wiggle seems to be starting in June, right? So like it may not be seasonality. It may just be random fluctuations, even though it kind of looks like a pattern. If it was a consistent pattern, then we should have taken it out with our seasonal indexes, right? So either our seasonal indexes have missed a little bit of seasonality there, and that's why we're seeing kind of that M shape show up a couple of times, or it's not actually a consistent pattern. And the fact that this one starts in May and the other one starts in June, maybe what's happening there. Right, so it's not regular. Anyway, right, the point is we have trend plus fluctuations, but no seasonality. And so we could forecast this using whatever method we like. I'm going to do a linear trend. So I'm going to click on this value here. There's not this series, right? The deseasonalized revenue, and I'm going to add a trend line. Now I can do the plus over here and then check off trend line, or in chart tools, I can go add chart element and check off linear trend line. Either way is all good, right? Once I have a trend line, see the dotted gray line here, I can format that trend line. First, I'm going to make it a little bit more visible. So I'm going to make it blue maybe. But second, I'm going to go to my options here in the bar chart looking thing, and I'm going to display the equation on the chart. So now I have my equation here. I can just move that over here so it's easier to see. This is the equation of the trend line, right? This is my blue line. This is the trend portion of the data once we've taken out the seasonality. So if you compare this slope to the slope we got in the other video when we were doing the regression only method, you'll see that it's probably pretty similar. Right? It should be. We're trying to essentially predict the same thing using a different method. They should be similar. And so then I can implement this formula in here to make a trend only prediction, or forecast. I should call it forecast. That's the term we're using here. And so with my trend only forecast, I'm just going to use this equation exactly, right? So I'm going to do 0.8591 times x. What is x? Now, x is time starting at 1. So it's this time variable here, right? There are some circumstances where you can use year instead of time or whatever, but this is not one of them. We would definitely want to use time here. Using year would be definitely wrong, because that's just not what x is referring to in this equation. All right, this is time starting at 1. And so then we're going to do plus the 294.07, right? These numbers are coming from this equation, which comes from my trend line. You could use the regression tool in data analysis as well to do a forecast where this deseasonalized revenue is your y values and time is your x values, and you will get the same numbers. You can do that if you like. This is getting us the same thing. So this is our trend only forecast, right? So this column here is represented by the blue dotted line on the graph. The deseasonalized revenue is the gray line. The actual revenue is the black line. And so now all that is left to do is to take these forecasts and add back in our seasonality. So we're doing the re-seasonalized forecast, right? Or you might call this a trend plus seasonality forecast, because we're forecasting the trend and the seasonality here. So all we do here, this one's very easy, is we take our trend only forecast and we multiply by our rescaled seasonal index. And we do that for each row. So we just copy and paste this all the way down. And there we go. This is done. This is our final answers. We can graph this and see how well it matches up to this black line. Right? So we can add this here. I'm going to just grab these numbers and there we go. I'm going to make this a dotted line just so it doesn't overlap the other line so much. Make it a little bit more visible. Right, so there we go. These are our forecasts, right? And we can see this orange is matching up pretty well with the black. There's a couple of times when we're off by a little bit, beginning here, down here in this valley, but it's overall quite good. And if you wanted to compare how good this one did compared to another model, such as the regression model we did in the last video, well, you can use any of the tools we did in module 2, right? We can look at the MAD or the MSE or the MAPE, whatever, right? So whichever one has the lower error is the one that's performing better. And so that's it. This is how we get our forecasts. And if we want to get them forecasting into the future, right, we can do that, right? So now watch out, this column here depends on this column here. And so what we need to do then, and this column here depends on time. So what we would need to do to get forecasts in the future is we would need to take this column here and continue it. Continue our time column all the way down as far as we like. And then we could continue with the time column going down as far as we like, we can take our trend only forecast and move that down as far as we like, right? So this is our trend only forecast going as far as we like. If we want to then put in the seasonality again, well, then we need to have those seasonal indexes again, right? Now our seasonal indexes were here, formula-wise, they depended on this month number thing here, right? So we could copy and paste the month numbers down and then just drag this down, or because these just repeat, there's just 12 of them and they repeat, what I can do is I can copy this and then going down here, I should just be able to right click and paste values as many times as I need, right? Because it's just the values are going to be the same, and it's the same 12 seasonal indexes. And so with these seasonal indexes and with these trend only forecasts, we can forecast into the future with seasonality by just dragging these down. Whoops, I did not do the rescaled ones. I should have done these 12, sorry, I did the wrong column, right? It was these ones I should be pasting values at, and you can see now it's working. Right, so I'm getting new forecasts into the future using the seasonal indexes, the 12 of them that we found, which don't change, and using the trend only forecast, which goes forwards with time. Okay, so there we go. That's everything for how we make forecasts using seasonal indexes. When you're trying to forecast things with seasonality, sometimes the regression method is going to be better. Sometimes the seasonal index method is going to be better. You can always try both and use our validation techniques from module 2 to determine which one is the best for your particular data. All right, so we're going to stop the video here, and I'll see you next time when we do another topic.